Hi everyone. Okay, we are going to go over the sine rule today. So previously you have been able to solve the unknown sides of triangles for right-angled triangles. Using SOHCAHTOA. Now what we want to be able to do is take that a little bit further and derive a couple of other rules that allow us to work out the sides of triangles even when they are not right angled. Okay, so I'm going to draw a triangle here and we are going to name this triangle A, B and C. Now I think we've spoken before about the way in which we name the sides of triangles. I think we did this when we talked about Heron's rule. When we have got a triangle that has got its vertices named in this way, what we do is we take the side opposite the angle and we name it the little letter. Okay, so what we're going to do is derive the sine rule. Now, if I have got a triangle here, and what I'm going to do is use some information that I have, knowing that if I call this H here, I know that the sine of C using SOHCAHTOA is going to be equal to the length of this H, height of the triangle, because that is a right angle triangle, divided by A. And likewise, I know that if I look at this angle here, I know that the sine of A is equal to H divided by C, which is the hypotenuse. Now I'm just going to rearrange those two equations over here. And I am going to, as we've done many times before, multiply both sides by A, and that will give me that H is equal to A sine C. And I'm going to do the same here. I'm going to multiply both sides by C, and I'm going to get that H is equal to C sine A. Now, what this does is it allows me to say that, given both this expression and this expression are equal to H, that in fact A sine C is equal to C sine A. And that can be written as A divided by sine A is equal to C divided by sine C. And if I redo this whole process again, I will also find that they are equal to B sine B. So this is the sine rule. and we only ever use two of these expressions at one time, so we might just do this one and this one, or we might do this one and this one. But what it does is it allows us to take four pieces of information, C, B and sign B, for example, and work out an unknown. Alright, so if I have a look at a second page, that might be the easiest thing. And I have got a triangle here, named in this way, but I've actually got some values here. I've got that that's 4, I've got that that's 32 degrees, I've got that that's 13, oops, I'll say that it's 41 degrees. Okay, and what I'm going to do is say that I want to know what B is. Alright, I'm going to say that B is equal to X. So I write down my sine rule, and that is B divided by sine B equals A divided by sine A. And then I plug in my values, so I have that X divided by sine 32 equals A divided by sine 41, gives me X equals 4 sine 32 divided by sine 41, which on my calculator is sine 32 times 4 divided by sine 41 equals 3.23. We'll say that they're metres, shall we? Okay, so what we're doing there is we are using that rule. Now, another way to write it is that sine A over A is equal to sine B over B, which is equal to sine C divided by C. Okay, so once you get used to it and practice a little bit, you will find it's actually quite a simple rule to use, and yeah, really useful.